Hello guys, welcome back. In this lecture I want to discuss the group 7 elements. Group 7 elements are elements which have 7 valence electrons in the outermost shell, right? So they've got 7 valence electrons and that's why they are put to this group 7. Now, instead of calling them group 7 elements, you can also call them fluorine family. But that name fluorine family is almost never used, right? Because there is a more common name, all right, which we call the group 7 elements. And what is this common name? It is the halogens. Group 7 elements are called halogens. Why? Because they are salt formers. Halos means salt, right? While gene, like genesis, means production or beginning. So the word halogens means salt formers, right? And that's what we call the group 7 elements more often. We don't call them group 7, we almost do not call them fluorine family, but we call them halogens, which signifies that they are salt formers. Right. Now, we established that apart from fluorine, which we mentioned as the first member of this group, what other members belong to group 7? What elements do you find in the 7th column of the periodic table? Now, these elements start from fluorine, like we said. Fluorine is F. Then we have chlorine. We have bromine. We have iodine. And we have astatine. These are group 7 elements. Fluorine, chlorine, bromine, iodine, and astatine, right? So every member here has got 7 valence electrons. You've got 7 valence electrons, and that's why they're put here. Okay, so what is your chemical properties? Now, before we move to their chemical properties, we said group 7 elements are salt formers, right? Okay, maybe we'll talk about that in the chemical properties. Let's leave that for later. And what is your chemical properties? Or let's say the physical and chemical properties as we've always done. So properties of the halogens. Properties of the halogens. Number 1, we'll start with the physical property. What is the state of matter? Fluorine and chlorine are gases at room temperature, right? What about bromine? Bromine is liquid at room temperature. It's liquid. And iodine is solid at room temperature. Astatine is almost never seen. The reason is because it is highly radioactive and unstable. So once it is produced in nature, it decomposes, right, to give more stable product by nuclear fission. Okay, so we talked about nuclear fission and radioactivity. Okay, iodine is a black solid. That's one physical property. What other physical properties do we have about these guys? What about their color? Their color, fluorine is a pale green gas. Right? Chlorine is greenish yellow. This is characteristic of fluorine gas. It is greenish yellow. Okay? In appearance. What do you call greenish yellow? Lemon. So you can say chlorine is a lemon gas. A greenish yellow gas. Okay? Bromine is a brown liquid. Bromine is a brown liquid. And iodine is a black solid. Iodine is black. Okay? At ordinary conditions. Now, most of us know iodine commonly as to as it facilitates, it kills germs on the surface of wounds and it facilitates quick recovery of wounds, right? Now, iodine, that iodine we know is kind of purplish black in appearance. Now, how come we're not saying iodine is black and not purple? Now, the iodine we apply to our wounds, okay, is tinctured iodine, which means it is tinctured iodine. And what does that mean? It is iodine dissolved in ethanol, in alcohol. So when you dissolve iodine in ethanol, okay, iodine being the solute, ethanol being the solvent, then you form tinctured iodine, right? You form tinctured iodine. And then you apply this to wound, it appears purplish, but pure iodine is a solid and it's black. So please take note of that. Okay, what about the chemical properties? What can we say about their chemical properties? We said they are salt formers. They are salt formers. Hence, are called halogens, right? They are salt formers. So it means that when you have a metal combined with a group 7 element, what you have is a salt. For example, potassium fluoride. Potassium is a metal, fluorine is a group 7 element, then this is a salt. Sodium chloride. Sodium is a metal, chlorine is a group 7 element, then this is a salt. Calcium bromide. Calcium is a metal, bromine is a group 7 element, then this is a salt. We have aluminum iodide. Aluminum is a metal, iodine is a group 7 element, then this is a salt. So you can form hundreds of salts. Just bring any metal, combine it with a group 7 element, then you have a salt. Or you can even combine group 7 elements with ammonium. For example, in ammonium chloride, then this also is a salt. So they are called salt formers because in most salts, group 7 elements are present. And that's what you've seen here. Okay? What other chemical properties do they have? What about the outermost electrons? They have 7 valence electrons. They have 7 valence electrons. That's why they are put in group 7 of the periodic table, right? And what about their block? What block do you think they belong? They are p block elements. The p block elements. Now let's explain points 4 and 5 together. Let's explain points 4 and 5. If you look at fluorine, which is the first member, it has an atomic number of 9. Taking the electronic configuration of this, we have 1s2, 2s2, right? 2p5. What does this tell you? That they've got 7 valence electrons because we have 2 here as a principal quantum number, and then by the time you add 2 to 5, right, it gives you a total of 7, which tells you that on the outermost electrons, or on the second share, you have got 7 electrons. What about chlorine? Atomic number is 17. And what does this mean? It means that my C should be uppercase. It means that you've got an electronic configuration which looks something like this. It means that on the third share, what do you have? You have 2 and 5 valence electrons, making a total of how many? Of 7 valence electrons. What block or what orbital do you find them? On the p orbital, because p orbital is where you find the last electrons, and that's the block they belong. How do they ionize? What can we say about the ionization? They ionize because they're in group 7, right? Means they require just 1 more electron to form a stable octet. So when they gain 1 electron, the 7 outermost electrons becomes 8, right? So the ionization is they ionize by gain of 1 valence electron, right, to form a uninegatively to form a uninegatively charged ion. So what does that mean? It means that if you took a fluorine atom, right, and then you add an electron to it, it becomes a fluoride ion. But you can see this is not balanced. So what happens? This is not balanced because group 7 elements are diatomic. So it means fluorine is F2, which is a diatomic gas. It means each of these fluorine atoms requires each electron. So that's why you have 2E minus to give us 2F minus. And this is a more reasonable appearance. This is a more reasonable form of the equation. The same thing happens to chlorine, also diatomic. All group 7 elements are diatomic. Each of the chlorine atom gains 2 electrons, and then it becomes that. You can see it, right? It becomes that. All right, what can we say about, okay, we already made a point that all members are diatomic. We don't need to write that. Now, we didn't mention this for group 6. For group 6, which is the previous lecture, they are ionized by gain of 2 electrons, right, to form a negatively charged ion. So let's just digress a little bit and discuss for group 6. Oxygen is diatomic, right? But before we talk about diatomic oxygen, let's take one atom of it. So oxygen here will gain 2 electrons to become a negatively charged ion. So it means that if you have oxygen as O2, oxygen will require 4 electrons to give us 2 oxide ions, as you can see. So for group 6, they are ionized by gain of 2 electrons to form a negatively charged ion. And that's for that, right? Okay, well, sorry, we didn't mention this in the previous lecture. Then back to group 7. What can we say about the oxidation state? They have an oxidation state. They have an oxidation state of -1, the more common form of it, or +7, the less common form of it. So the oxidation state of chlorine in NaCl is -1, right? Oxidation state of fluorine here is -1. The oxidation state of bromine, in the example we gave earlier, is -1. And then we've talked about calculation of oxidation number. Oxidation number, or call it oxidation state, right? We've discussed calculation of oxidation number in our lecture on oxidation and reduction. So you know how to calculate the oxidation number of the halogens here and determine that. Now let's go back, let's digress again to group 6. Group 6 have oxidation states of -2, common form, of +6, right, or +4. So they have an oxidation state of -2, +6, or positive. This is for group 6 elements. What does this mean? It means that, okay, let's take an example. If you have oxidation state of sulfur here, this is sulfur 4 oxide, right? Of course, sulfur here, you want to calculate its oxidation number plus. Oxygen has an oxidation number of -2. So when you multiply this by -2, it gives you 0. Why is it equals to 0? Because it's a stable compound. We talked about this in oxidation and reduction. This gives -4, and this gives +4. So oxidation state of sulfur here is +4, right? So you can see sulfur is a group 6 element, yet has an oxidation state of +4. Oxygen is a group 6 element here. It has an oxidation state of -2, right? Now, if I ask you to calculate the oxidation state of sulfur here, this is tetraoxosulfate 6 acid. Tetraoxosulfate 6. It tells you that the oxidation state of sulfur here is +6, right? Okay, let's calculate it so you will understand. But then we are cognizant of time. We don't want to. Hydrogen has an oxidation state of +1, sulfur S. Oxygen has an oxidation state of -2, and this equals 0 because it's a neutral compound. So 2 times plus 1 is plus 2, plus sulfur plus 4 times negative 2 is negative 8. So this gives us negative 8 equal to 0. Plus 2 minus 8 is minus 6 equal to 0. When you take 6 to the other side, it becomes plus 6. So sulfur here has an oxidation state of plus 6, right? Sulfur here also has an oxidation state of plus 6 in SO3. Of course, sulfur is here. Sulfur plus 3 times oxygen, which is minus 2, gives us 0. And this gives us minus 6. Crossing minus 6 to the other side of the equality sign tells you sulfur has an oxidation state of plus 6. So for group 6, you can have oxidation state of negative 2 plus positive 6 or positive 4. But for group 7, you have oxidation state of negative 1, which is a more common form, of positive 7, which is rarely seen, right? That is another point. Now, let's round off with this point. That, where is it? That these elements, they have the greatest oxidizing ability compared to group 6, group 5, and every element in the periodic table, right? In the periodic table. Now, what can you say about this? What can you say about this? Group 1 elements they are the best reducing agents, right? In the whole of the periodic table, group 1 elements, or we call them the alkali metals, are the best reducing agents. What about group 7? They're the best oxidizing agents. So you can see the two extremes, right? And the reason is because group 1 elements easily lose 1 electron, hence make them very good reducing agents. Or group 7 elements gain 1 electron, hence makes them good oxidizing agents. And that's it about group 7 elements. I hope it was fun. I hope you learned. And now I'm sure you know why they are called halogens. So please run through the chemical processes and make sure you understand each of the chemical properties. You can as well add more properties if you wish, right, to the list. So thank you for sticking with us. In the next lecture, we'll talk about the group 0 elements. We shall see in the next lecture.